Hey everyone, and welcome back to the channel. Today we're diving deep into the fiery heart of one of America's most iconic volcanoes, Mount Hood. We're talking about a mountain that looks serene and beautiful from afar, but has a truly dynamic and explosive past. And guess what? The secret to its historical eruptions, the very trigger that often sets it off, lies in something absolutely fascinating called magma mixing. Now, you might think volcanoes just have one big pool of molten rock, right? Well, it's a bit more complex and a lot more exciting than that. Imagine Mount Hood sitting there seemingly dormant, but underneath, miles beneath the surface, there's a complex plumbing system. For a long time, scientists have been studying the evidence left behind by Mount Hood's past eruptions. The rocks, the ash, the way different minerals crystallized. And what they've found is a consistent pattern. A signature of different magmas meeting and mingling just before a big event. So, what exactly is magma mixing? Think of it like this. Deep down, there can be different batches of magma, each with its own unique composition, temperature, and gas content. You might have one type of magma, say a cooler, more evolved magma, sitting in a chamber. Then a fresh batch of hotter, less evolved magma from deeper within the earth starts to ascend and intrude into that existing chamber. It's like pouring hot water into a cup of cooler water. Things are going to get interesting. When these two distinct magmas meet, it's not just a gentle swirl, it's a violent chemical and physical reaction. The hotter magma acts like a catalyst, superheating the cooler, more viscous magma already present. This sudden temperature increase causes gases, which were previously dissolved in the magma under high pressure, to exsolve. Essentially, they bubble out. Imagine shaking a soda can. The pressure builds rapidly. This rapid exhalation of gases significantly increases the pressure inside the magma chamber, making it extremely unstable. This pressure buildup is the critical trigger. The now agitated, superheated, and gas-rich magma becomes buoyant and wants to escape. It pushes against the surrounding rock, creating fractures and pathways until, eventually, it finds a way to the surface. Boom. You have an eruption. It's a bit like a pressure cooker reaching its limit. The mixing of these different magma types doesn't just create a trigger, it also gives Mount Hood's eruptions their distinct chemical fingerprints, which scientists can then analyze to reconstruct its fiery history. The evidence for this magma mixing at Mount Hood is written all over the rocks it's produced over thousands of years. Geologists look at individual crystals within volcanic rocks, like feldspar and amphibole. They often find zoned crystals, meaning they have different layers of composition, much like tree rings that record changes in the magma's environment. These zones tell a story of crystals growing in one type of magma, then being suddenly plunged into a different, hotter magma as mixing occurred, causing new layers to grow quickly. It's like finding a geological diary within each crystal. For example, studies of Mount Hood's eruptions over the last 15,000 years, particularly the significant events like the Old Maid eruption complex around 200 to 300 years ago, show clear signs of this process. The erupted lavas and pyroclastic flows contain minerals that crystallized from both the hotter incoming magma and the cooler resident magma, all mixed together just before eruption. This isn't just theory. It's tangible evidence extracted from the very heart of the mountain's past outbursts. Understanding magma mixing is crucial not just for Mount Hood, but for many other volcanoes around the world. It helps us predict what kind of eruption might occur, how explosive it could be, and potentially even when. By monitoring changes in seismic activity, ground deformation, and gas emissions, volcanologists are always looking for signs that fresh magma might be ascending and beginning to interact with existing magma bodies beneath volcanoes. It's a complex puzzle, but each piece, like magma mixing, brings us closer to understanding these powerful natural forces. So the next time you gaze upon the majestic Mount Hood, remember that beneath its tranquil exterior lies a dynamic, ever-changing system where different magmas are constantly on the move, sometimes meeting in explosive encounters that have shaped its dramatic history. It's a powerful reminder of the incredible forces at play beneath our feet. That's all for today's deep dive into Mount Hood's fiery past. I hope you found this exploration of magma mixing as fascinating as I do. If you learned something new or enjoyed the video, Please hit that like button, share it with your friends, and don't forget to subscribe for more awesome science content every week. Your support helps us keep bringing you these incredible stories from our amazing planet. Thanks for watching, and I'll see you in the next one.